the vertical line test says, if we have a function, a vertical line will not hit the graph in more than one place. So for example, we'll go to here. We're trying to determine if we have a function. This is a curve, so it's not a straight line that's going out. This is a square root function, okay? This is the graph of what a square root would look like. So can I draw a vertical line anywhere and hit the graph in more than one place? Or is it just hitting the curve in only one spot? It's only hitting in one spot, right? I'm not hitting it in two places. So this would be an example of using the vertical line test. We know that this is a picture of a function. So is this a function? We'll say yes. Okay? So then the horizontal line test is just the same thing as the vertical line test, only it's the horizontal line test. Does a horizontal line hit the graph in more than one place? If yes, then that means the inverse is not a function. If it's no, then the inverse is a function. Are we clear on that? So we'll look at this one again. Can I draw a horizontal line, and does it hit it anywhere other than at one point? No. So is the inverse a function? Then it would be yes. Yes, because it can't. We don't want the horizontal line or the vertical line hitting in the graph in more than one spot. It can only hit once on that graph. Okay? What about this next one, a parabola? It must pass the vertical line test first. Does it pass the vertical line test? So it's a function. Does it pass the horizontal line test? Nope. There it hits it in two spots. So is the inverse a function? No. Okay. Haley? Why don't you just watch? Or print these out. Just kind of watch. Because they'll be, I know the printed out notes are loaded. Okay. All right. So how do we show if two functions are, how do we show if they are inverses? We do our composition. We do f of g of x, and we do g at f of x. And when we do those compositions, both must simplify strictly down to x. Okay. So if f of x is equal to x minus 1 over 2, and g of x is equal to 2x plus 1, if I do f at g of x, that means in my f function I'm putting in 2x plus 1. Does that make sense? And so my f function says instead of an x minus 1, I'm going to put 2x plus 1 and then minus 1 over 2. Well, that's 2x over 2, because your 1's will drop out, correct? Which becomes just x. And if I do g at f of x, then in for my g function, I'm going to put x minus 1 over 2, which then is going to be twice what? X minus 1 over 2, and then plus 1. And what's going to happen here? The 2's drop out, and what am I left with? X minus 1 plus 1, which is, so I got an x here, and I got an x here. So because I got x in both cases when I'm doing my substitution, those two equations are inverse functions of each other. Okay? All right. So let's see what this is really saying on a graph. Anybody got a question? All I did was a substitution. So these are my functions. I gave them to you. If I'm doing f of g of x, which is what I have to do, and my g of x is defined to be 2x plus 1, I'm going to put that in to this spot right here. So that's 2x plus 1 minus 1 over 2. The 1's drop out, the 2's cancel, and I get x. And I have to get x. That's the only answer I can get if there's to be inverses of each other. And then I did it the other way because I have to do it both ways, g at f of x. That's the definition of inverse. And you'll see in a second what's going on. Okay? But that's the only way to prove it. Okay? All right, so find a rule for g inverse. This is saying the inverse function of g at x. G to the negative 1. It's an exponent, but it stays with the function. That's just the little script that says that we're doing an inverse function. Okay. If I give you g of x is equal to 4 over x, let's sketch it. Okay, and I want you to tell me what the domain is. What is the domain for 4x? X is an element of the reals. Okay? This is a graph of a what? A line, all right? So we'll put, I'm not going to have you graph this using your slope method, and you'll see why in a second. We're going to pick some points. Let it 1 be negative, 1 be 0, 1 be positive. If x is negative 1, we get negative. If x is 0, we get. And if x is 1, we get. Okay. You might want to get another piece of, or another pen out or another color just so that we kind of color coordinate what we're doing here. All right, but the negative 1, we get 1, 2, 3, 4, 0, 0, and 1, 4. So this is the graph, and we knew it was going to be a line of our function. And if we had to determine what our range was going to be, which are our y values, do we have any limitations to what y is ever going to be? Is y going to be positive? Negative? 0? You got tails going on in both directions. Agreed? So our range, which are our y values, is y is an element of the reals also. Are we good so far? Mm-hmm. And you really look at your range right here. That's why I'm having you do this chart. I can, for any x value, I'm going to get any y value. I'm going to get positive, negatives, and zeros. Okay? If you've got a question, you need to raise your hand and ask me a question. Okay? Alex? My graph goes on and on, right? So doesn't it go to negative infinity and positive infinity of our y's? And aren't our x's going to positive infinity and negative infinity? So we've got nothing that it can't ever be. We're using all of our number systems for our x and our y-axis. So look at your tails to help you. Okay? Michelle? Just positive and negative and 0. Well, use x as 0. Use that as a possible value for your chart. And then just look at your tails and see what they're doing. Okay? I'll show you. Okay? We'll do a lot of variations, yes. I haven't done the inverse yet. Okay? All right, so here's the rule for the inverse. Okay? This is something new. You've never had it. This is a hard chapter, so you've got to ask me questions as we go along. You've not had any of this material, so this will all be new. Okay? All right, so we're going to do the inverse. And I didn't leave a lot of room here, so we might do this one on another piece of paper, okay, or on the flip side. All right, here's the inverse for the rule. The inverse to figure out the rule to figure out your inverse is, number 1, switch the x and the y. So this says that g of x is equal to 4x, which really means y equals 4x, correct? So if I give you y equals 4x, and I'm switching my x and my y, then what am I going to write? X equals 4y. So I've switched my x and my y. And step 2 is to solve for y in my new equation. And so if I'm solving for y, I'm going to get x over 4 equals y. Would you agree? Now, we need to know that this wasn't the original function, so we're going to put that little -1, because that means that's the inverse equation. That doesn't move to the other sign. It's not an exponent. It's just an indication that we are dealing with an inverse function. Okay? So, we're going to do our domain and our range for this. What is our domain? For this one, do I have a square root? Do I have a variable in the denominator? So x is an element of the reals. We're going to do a little chart. I'm going to use 0. If x is 0, what do I get? I'm going to use, because I don't like fractions, I'm going to use 4. If x is 4, what do I get? And we'll do -4. If x is -4, what do I get? What did you just see happened? Look at this chart. Look at this chart. Why would they be opposites? Because what did I do? I switched the x and the y. So this graph is going to be 0, 0, 1, 2, 3, 4, 1, 1, 2, 3, 4, -1. This is the graph of the inverse. Then just get it. Okay, the inverse is a reflection of your graph over what line?
The x-axis.
What did you switch? So it's a reflection over the line y equals x. The inverse function is a reflection of your graph over the line y equals x, because we're switching the x and the y. So this was my original one, and I flipped it, and I reflected it. This one was my original one, and I reflected it over the line y equals x, and here it is. Okay? So all of these, when we come up with our inverses, will be reflected over the line y equals x. Well, guess what? If the domain was a set of reals, and the range was a set of reals for my original function, and I switched the x and the y to come up with my new function, what are we going to do with the domain and the range for our inverse function? So the domain of the inverse function is what? The range of your original. Okay? So what is x going to be an element here of? The reals, but we're looking at the y value here, right? And what is your range going to be? Well, we'll really look at the range, the domain. So y is an element of the reals. So here are my domains. Here is my rule for my inverse function. And this is the graph of both of them. So all you really have to do is make one chart, don't you? If you know what your chart is, and you graph your equation, if you're trying to graph your inverse, you're just flip-flopping these. You should make sure that they're right. Grace? When I'm asking you for the inverse function, it has to have that -1. If you drop it, then you're telling me it's just a regular function, and that's incorrect. Okay? All right. Here we go. Could you please body graph y equals x to the 6th? Oh, we did body graphing in here. Body graph. Even roots, where do your tails go? Or even exponents? Up. This is positive, so we're reaching for the sky. Okay? So we don't care what's going on. These are our tails. Does this pass the vertical line test?
Yes.
Does this pass the horizontal line test? So if we want to be able to come up with the function and its inverse, we have to limit our domain because our domain is x is the element of the reals, and y would be what? What do you think the lowest point on this is going to be? 0. So this, x to the 6, is kind of something that looks like this. Okay? Which if I just graph this would be telling me that x is an element of the, is it? Yes. And y would, what would happen with y? Or equal to 0, right? But this limits my domain. What does that do to my graph? So if I'm only wanting x greater than or equal to 0, do I want the right part of my graph or the left part? Right. Okay, so let's do this. Let's do this using our chart. So what is our real domain going to have to be? Hold on. What is our real domain going to be? It's determined by the fact that we limited it. Limited it. Okay? Why? Who said why? Okay, why did we limit? Because it fails the vertical line test. Or the horizontal line test. Right. It has to pass the vertical, and it has to pass the horizontal. This fails the horizontal. This passes the horizontal. And when or this way. And so when I say x is greater than or equal to 0, I'm using this portion of my graph. I'm eliminating this portion. But I'll usually tell you what side to use. Okay. Or you can, if I don't, then you can choose one or the other, and that's fine. Okay. So let's figure out our domain. Let's look at our chart. What's the first value that x has to be? Can I use any negative values? No. What's the first value I need to use? 0, because that's what our domain is saying. So if x is 0, what's y? 0. And then I need 3 points. I know that my tail has to go along the y-axis, correct? Because you just told me by body graphing that my tails are doing this, yes? All right. So then let's use 1, and 1 to the 6th is, and let's use 2, and 2 to the 6th is 32. 2, 4, 8, 16, 32, 64. I did that right. Okay, so 0, 0, 1, 1, and 264 is way the heck up here. What is my domain now? Look at your chart. Domain is x greater than 0. What's our range? That's what I meant to ask. Right, greater than or equal to, because I got 0. So our chart will help us figure out our range. Okay? Let's not worry about our rule, but let's come up with the chart for the inverse. What? If x is greater than or equal to 0, we will only get positive values. And 0 is the first one that I have to use because that's defined by my domain. Okay? All right. So for my inverse, I'm just going to do what? Flip them. So I'm graphing 0, 0, and 64, 2. So 0, 0, 1, 1, and 64, 2 is way the heck that way. And isn't it still symmetrical to the line y equals x? Because if you fold a paper on that line, won't you get those two pictures on top of each other? Yeah. Technically, that's how it should work, assuming your graphing is not weird. Okay. So let's do this. What's the domain going to be? X is greater than or equal to, and what's my range? Your chart will help you, right? right? Your chart will help you. Your chart for the inverse is this. Or flip-flop these, right? You following this? The domain of my original becomes the range value of my inverse. The range of my original flip-flops and becomes the domain of my inverse. No. Well, there might be different values, but the pattern is the same. Okay? So that means now we need to find the rule. Y equals x to the 6. What's my next step? X equals y to the 6. Y equals plus and minus the 6th root of x. Y to the negative 1, right? Do I really want that, though? Do I really want positive and negative? Look at my graph. What am I really wanting? Only the positive one, because I'm dropping out the negative. Because the negative would have been this bottom portion of my graph. Does that make sense? So my rule is really going to be just the positive root of x. Positive 6th root of x. Okay. Body graph this for me. Negative and x cubed. Just tell me your tails. Negative and a cubic. Is it this way or this way? This is what does this pass the vertical line test? Will it also pass the horizontal? So do we need to limit our, no, we don't have to limit our domain because we can use everything. So remember, do I have a square root? Do I have a denominator? What's my domain? So if my tails go on, x goes to positive infinity and negative infinity, and what does y do? Positive. And so what's my range going to be? Element of the, all right. All right. So let's do our little graph. Use a negative value, use 0, and use a positive value. So at negative 1, I'm going to get 6. At 0, I'm going to get, and at 1, I'll get, so 0, 1, 2, 3, 4, 5. Negative 1 is 6, and 1 is 4. And so remember, this does a little bitty loop-de-loop. And remember, exponents hug the y-axis. Write that down. Exponents hug the y-axis. So what do you think roots are going to hug? The x-axis. Okay? What is the chart for the inverse? Right, we're just flip-flopping them. We've got that chart already made. Now we're going to graph it. So 1, 2, 3, 4, 5, 6, negative 1, 0, 5, and I did something wrong. Hold on, I did this wrong. It's 6, negative 1. 1, 2, 3, 4, 5, 6, negative 1. And so it's coming and doing this. And is it symmetric to the line y equals x? It will always be. It will always be symmetric to the line y equals x. Why? Because to come up with the inverse, we switch the x and the y. Sorry. So let's do our rule. If y equals negative x to the third plus 5, then we're going to say x is equal to negative y to the third plus 5. And now let's solve. What do I do? Okay. Plus 5 equals y to the third. Move the negative sign. Equals y to the negative 1. Why did I do what? You've got to show that that's the inverse by putting that negative 1. Because this rule is the equation of that line. Mhm. Now, as long as you've got all the work, if you're a little funny on your graph, and that's okay. However, make sure that you do exponents go up and down and roots go left and right. If you have your roots going up and down and your exponents going left and right, I will count that wrong. Okay? All right. Yes. In other words, if you graph something like this, like that, that's wrong. Exponents go up and down. Because I'm only making you do 3 points. So if from those 3 points you decide to make your tails go left, right instead of up and down, then I would say that's wrong. Okay? All right, I'm going to skip that one for right now. And let's go to this one. It's the last page. Yeah. So we have a little more room. Okay. What is this in shape of? You got to know what these look like. Parabola, up or down? Down. Why is it down? Okay. Does it pass the vertical line test? Yes. Does it pass the horizontal? Change your domain. Instead of reals, do you want this part or this part? Doesn't matter which one, but I like just always doing this. I just like always making it greater than or equal to 0. You know that this is going to be this. You know that that's what that's going to look like because it's a parabola pointed down. And if I want greater than or equal to 0 for x, then I want this part of my graph.
Oh, okay, got it.
Got it? And now that passes both the vertical and the horizontal. Okay? So now let's do our little chart. If x is 0, you got to use this as your first value if you're limiting your domain. That has to be your first point. So if x is 0, y is? If x is 1, y is? And if x is 2, y is? So 0, 1, 2, 3, 4, 1, 3, 2, 0. We know it's doing that. I need to get through this first. Okay? What is my range? Y is, careful, less than or equal to what?
4.
What? Look at your chart. What is y less than or equal to?
4.
Oh, my bad.
4.
Yeah, you're right. All right, wait. We're going to finish this. So, okay, so here we go. Here we go. For our inverse, this is why I wanted to do this. For our inverse, what's our domain going to be? Less than or equal to 4. The domain of the range flip. What's the domain of the range going to be? Okay. Yep, 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 yep. I just always go positive. That's just personal preference.